We present dataset and benchmarks for task-oriented log dialog ranking task. This paper is in the proceeding of INTERSPEECH 2020. The data-driven approach of some recent bot building platforms make it possible for a wide range of users to easily create dialog systems. Developers train and deploy the dialog system through dialog building platforms. Then real users interact with the system and generate log dialogues. The developers review the logs to identify which log dialogues contain problems and update the training process to fix the problems. However, those platforms do not offer tools for quickly identifying problematic dialogues. Due to the sheer volume of log dialogues, the process of upgrading the system with the human in the loop can be significantly slow. To solve this problem, in this paper, we introduce a new task, log dialog ranking, where the ranker places problematic dialogues higher. Then we provide a collection of human-bot conversations in the restaurant inquiry task, labeled with dialogue quality for rankers training and evaluation. We also present a detailed description of the data collection pipeline, which is entirely based on the crowdsourcing. Finally, we report the benchmark results of the log dialog ranking, which shows the usability of the data and that sets a baseline for the future studies. In this video, I will introduce these three main contributions individually. First, let's look at the descriptions of new task, log dialog ranking. Let's start with an example of the log dialogues in the restaurant searching area, happened between the user and the restaurant searching bot. The dialogue starts with the greeting message from the restaurant searching bot. The user is looking for the address of a European restaurant in the city center with an expensive price range. As we can see, this dialogue contains two problematic terms. In the previous turn, the user wants to find a venue in the city center. However, the bot suggests a restaurant in the east of the town. Also, when the user is asking for the address of the restaurant, instead of answering the user's question, the system repeats the questions that the user has answered before. That breaks the entire flow of the conversation. We call these problematic turns as contextually unnatural turns. By the end of this conversation, after the performance of the system went wrong, the user ends the conversation without achieving her goal. We call this as a conversation with an unachieved goal. Therefore, we define the problematic dialogues as the dialogues either with contextually unnatural turns or with unachieved requirements, or with both. However, if the system is able to understand the user's utterance and performs in a logical way, we will end up with the normal dialogue. In this normal dialogue, the system finds the user a cafe in the city center, which follows the user's requirements. After that, when the user is asking for the address of the cafe, the system answers it with the relevant information. The entire dialogue ends smoothly in the end, with the user achieved all her requirements. Therefore, contrary to the problematic dialogues, we define the normal dialogues as the dialogues without any unnatural turns and without any unachieved goals. On top of the definitions of the normal dialogues and the problematic dialogues, we define the log dialog ranking task as creating a dialog ranker aims to assign higher scores to the problematic dialogues than the normal ones, so that problematic dialogues can be identified easily in the ranked list of log dialogues. For the newly defined log dialogue ranking task, we provide a collection of human-bot conversations in the restaurant inquiry task, labeled with dialogue qualities for the ranker's training and evaluation. Let's look at the data collection process and some statistical results for the log dialogue ranking dataset. The aim of the data collection process is to collect human-bot conversations with labels of dialogue quality. We used Amazon Mechanic Turk for the data collection. Firstly, we deployed the PyDial restaurant bot to the EMT platform. The task for the bot is to search for restaurants based on users' requirements in multi-turn natural language communication. Then we automatically generated a set of searching requirements. In this example, we have food type as Cantonese, area as center of the town, price range as expensive. After that, we asked the Turkers to find restaurants that satisfy these requirements by chatting with the restaurant bot. At the end of each task, Turkers are required to answer a questionnaire including 2 questions. First, whether they found restaurants satisfying their requirements. Second, label contextually and natural terms in the conversations they experienced. From the collected dialogues, we labeled successful dialogues without any contextually unnatural terms as 0, normal dialogue, and the rest as 1, problematic dialogue. For example, in this case, the Turker labeled the conversation as successful, but with 2 unnatural terms. So we classified the conversation as a problematic dialogue. In general, we collect almost 1,500 normal dialogues and almost 1,900 problematic dialogues, with average dialogue length as roughly 6 turns and 8 turns respectively. We randomly split the corpus into trend, validation, test set. Finally, I will have an introduction about our benchmarks over this log dialogue ranking task. We introduced 2 document classification models as the baseline of the dialogue ranking task. The first baseline is called bidirectional STM plus MLP. We first used bidirectional LSTM to encode utterances in the dialogue. After that, we applied a feed-forward neural network followed by a sigmoid activation to each pair of system user utterance to measure the consistency. Finally, the ranker produced a ranking score for the dialogue based on all the consistency scores. The second baseline is called hierarchical attention. We just simply use 2 levels of bidirectional STM, word level and the dialogue level to encode each utterance and the entire dialogue respectively. On top of that, we applied the feed-forward neural network followed by the sigmoid activations to the embeddings of the dialogues and predict the ranking score for the dialogue. We use ranking matrix precision at K for evaluation, which corresponds to the number of problematic dialogues in the top K ranked options. From the table, we can see that except for the precision at 30, hierarchical attention is either same with or outperforms bidirectional STM plus MLP. Both methods achieve over 90% precision in top 50 ranked dialogues. It proves that the rankers trained on the collected data are helpful for developers to discriminate problematic dialogues in the practice. However, the accuracy drops when the K is over 100. It shows the challenges of this log dialogue ranking task. Thanks for watching.